Hey everyone! Today we're diving into something that's not always glamorous, but is maybe the most important part of data science: data cleaning. Seriously, this is the absolute foundation for any analysis you can trust. So let's get into it. You've probably heard this phrase before, right? And in the world of data, it's the golden rule. It means if you feed your analysis messy, unreliable data, your results are going to be, well, useless. This isn't just some abstract problem, you know? It can lead to bad business decisions, biased AI, and just plain wrong conclusions. It doesn't matter how fancy your algorithm is. You just can't cook a five-star meal with spoiled ingredients. So to make this all super clear, we're going to frame this whole process as a kitchen rescue. Just imagine our raw data is like a messy bag of groceries. We've got cracked eggs, some rocks mixed in with the flour, maybe the salt and sugar got switched. Our job today is to clean up this mess and prep these ingredients so they're perfect for the amazing analysis we want to build. So here's our game plan. First, we'll take a good hard look at our messy ingredients. Then we'll get into column cleanup, tackle the core cleaning, add a final polish, and then at the very end, reveal our sparkling clean data all ready for analysis. All right, let's get to it. First up, we have to inspect the mess. We're looking at some pretend survey data from students about their gaming habits. This is totally raw, straight from the source, and as you're about to see, it is full of little problems we need to sort out. And here we go. Yikes. Right away, you can see the column names like Q1_name are pretty confusing. We've got two entries for Alex. Maybe they hit submit twice, and look at Emma's age, 200. Yeah, probably not. Then in the console column, you see yes and yes. To a computer, those are two totally different things. And my favorite, in the hours column, someone literally spelled out the word 8. So this is our messy kitchen. This is our starting point. Let's start with an easy win that just makes everything else so much simpler: giving our columns names that actually make sense. You know, labels like Q1 and Q2 just aren't going to cut it if we want our analysis to be clear. The tool for this job is the rename function, and it comes from Pandas, which is an absolutely essential Python library for this kind of work. The syntax here is actually really nice and intuitive. We're telling our data frame, which is called df, to rename its columns. Then we pass in a Python dictionary. That's what the curly braces mean. And each entry is just a pair: the old messy name, followed by a colon, and then the new clean name we want. It's a really direct, readable way to make our data a whole lot more understandable in one fell swoop. Okay, with our columns looking good, we can now roll up our sleeves and dive into fixing the actual data inside the table. This is really the heart of our kitchen rescue. We're going to tackle this in 3 key steps. First, we'll hunt down and get rid of any duplicate rows. Second, we're going to fix columns where the data is stored in the wrong format. And third, we'll figure out a smart way to handle any missing values. So, our first problem: duplicates. See here, the first and fourth rows for Alex are exactly the same. Now, why does this matter? Well, if we wanted to calculate the average age of the students, Alex's age would get counted twice, and that would throw off our results. We've got to remove that echo. And luckily, the fix for this is just beautiful in its simplicity. The function is called drop_duplicates. It scans the whole data set, finds any row that's an exact copy of another one, and just gets rid of it. By default, it keeps the first one it finds and tosses out the rest. One simple line of code, and poof, our duplicate problem is gone. All right, next up is a tricky one in the weekly hours column. You see, most entries are numbers, but because one person typed out the word 8, Pandas has to play it safe and treat the entire column as text, what it calls an object data type. And this little table shows you exactly why that's such a big deal. You can't ask a computer to find the average of the word 8 and the number 10.5. It just doesn't compute. It'll throw an error. We absolutely need this entire column to be numeric so we can do math on it. So, to fix this, we use the PD to numeric function. We tell it what column to work on, in this case, df/weekly hours. But the real secret sauce is that errors equals coerce part. This is us telling Pandas, hey, try your best to turn everything into a number. But if you hit something you can't convert, like the word 8, don't panic and crash. Instead, just coerce it into a special placeholder called nan, which just means not a number. And here's what we get. Our 8 has been successfully turned into a nan, a missing value. But if you look closely, we already had a missing value from Mike to begin with. So now we've actually got 2 gaps in our data. If we just leave them there, we might have to exclude these students from our analysis, which we don't want to do. We need a better plan. So this process of smartly filling in the gaps is called imputation, and our tool for that is fill-NA. What we're going to do is fill those missing spots with the average, or the mean, of all the other numbers in that column. It's a really common and statistically sound way to fill in those blanks without having to throw away the whole row. We are on the home stretch now. It's time for the final polish. These last two steps are all about making sure our data is consistent and, maybe more importantly, actually believable. So take a look at the owns console column. To you and me, yes with a lowercase y, yes in all caps, and yes with a capital Y all mean the exact same thing. But to a computer, nope, those are three completely different text values. If we tried to count how many students own a console right now, our numbers would be all wrong. The fix for this is another one that's super simple and elegant. We can just add .str.lower to the end of our column. This basically tells pandas, hey, for this column, treat everything as a string and then apply the lower function to every single entry. So yes becomes yes becomes yes, and just like that, everything is perfectly standardized. So easy. And now for our final problem, an outlier. An outlier is a data point that is either totally impossible or just so extreme that it's going to warp our results. In this case, Emma's age being 200. It's obviously a typo, but if we left it in and tried to calculate the average age of these students, that one single number would completely wreck our result. To deal with this, we use something called filtering. Now, this code, df age less than 100, might look a bit weird, but let's break it down. The part inside the square brackets, df age less than 100, is basically asking a question for every single row. Is the age in this row less than 100? It then makes a list of true or false answers. Then, the outer df filter part uses that list as a filter, and it only keeps the rows that got a true. So we're not actually deleting Emma's row, we're just selecting all the other rows that fit our condition. It's a much safer way to do it. And with that, our kitchen rescue is officially complete. Every one of our messy ingredients has been washed, chopped, standardized, and prepared. Let's take a look at the final product. And there it is. Just look at that. Our clean, pristine, analysis-ready data set. The column names are perfectly clear. The duplicate Alex is gone. The weekly_hours column is all numbers, no missing values. The owns_ column is totally consistent. And that impossible age of 200 is out of there. This is data we can finally trust. We've done all the crucial prep work. The data is now clean, reliable, and structured properly. And this is where the real fun starts. Now we can build charts, calculate insights, maybe even train a machine learning model. The possibilities are endless, but they all had to start right here, with cleaning. So the only question left is, what amazing meal will you cook with it?